Okay, so now we're going to solve each of the following and then graph the solution set. A, we have the inequality 8x minus 7 greater than 6x plus 3. So just like an equation, we solve it the same ways, but keep in mind the properties of inequalities. So we need to, say, isolate the x on one side. I like to put the x's on the left-hand side, so I'm going to go ahead and subtract 6x on both sides there. Okay, so this would give me 2x minus 7 greater than 3. And then I would add 7 on both sides to get 2x greater than 10. And then I would divide both sides by 2 to get x is greater than 5. Okay, well, the solution set for this in set notation or set builder notation is the set of x such that x is greater than 5. However, in interval notation, this would be, this interval notation would be open parenthesis c, 5 to positive infinity. Okay, so now for to graph the solution set, then we would have a number line. For instance, we would have, say, not negative, but say like 2, 3, 4, 5, 6, 7, and maybe 8 there. And then have an open circle at 5, indicating we're not including 5, and then shade everything to the right, going that way. That represents all the numbers that are greater than 5. Okay, so for part B here, we have negative 5 over 6x less than or equal to 3/4 plus 8 over 3x. Okay, so I like to, since these have fractions, I like to build up each of these fractions to have the same denominator. In other words, the least common denominator. So for this particular problem, I would multiply, the least common denominator is 12. And so I would multiply top and bottom here by 2, top and bottom here by 3, and then top and bottom here by 4. So this way we have new fractions that have denominators of 12, equivalent fractions, I should say. A negative 10 over 12, x is less than or equal to 9 over 12, plus 24, I'm sorry, not 24, 32 over 12x. Okay, so then I say forget about the denominators and write whatever's left in the numerator. And that's our equation there. All right, now I solve this equation. Once again, I like to get the x terms on the left-hand side. That's just my preference. Okay, so then on the left side, we get negative 42x, which is less than or equal to 9. And then I would divide both sides by a negative 42, which happens to change the inequality to greater than or equal because of our properties of inequalities. And doing so gives us the final answer that x is greater than or equal to negative, and then of course 9 over 42 has at least a 3 in common, and so we could divide out a 3 to get a negative 3 over 14. Okay, so in set builder notation, that's x such that x is greater than or equal to negative 3 over 14. And interval notation, we would have a bracket negative 3 over 14, and then shade everything to, we're not shading right now, but we want everything to the right of it, so we're going to positive infinity. In other words, the interval negative 3/14 is close to 0, between negative 1 and 0, and maybe something like that there when we draw the number line. And then we would have a filled in circle at negative 3/14. It's probably closer to 0 than it is to negative 1, so I'll write it there. And then I would shade everything to the right of it.
And that would be
the graph of the solution set.